This is the official nautical chart of the Layskoll Reef. On January 13, 2012, the cruise ship Costa Concordia struck the submerged rock indicated by the blue circle, positioned at a depth of 7.3 meters, directly adjacent to the dry rocks marked by the red arrow. The voyage had begun in Civitavecchia with a standard route toward Savona, but the impact occurred inside this deviation box off the coast of Giglio Island. Meteorological conditions were favorable, the ship's equipment was fully functional, and the reef was a documented navigational hazard. Investigators attributed the primary cause to Captain Francesco Schettino, who performed an unauthorized deviation from the planned course to conduct a close coast salute maneuver. However, technologically advanced vessels do not strike mapped hazards solely due to a single bad steering command. Stopping the investigation at human error overlooks the complexities of maritime safety. The grounding must be analyzed as a sequence of systemic failures. The rogue operator narrative is often inadequate for explaining accidents in complex maritime systems, where multiple layers of defense are supposed to catch individual mistakes. To understand these failures, we use James Reason's organizational accident model as our analytical framework. Layer 1 consists of active errors, the immediate physical mistakes made by the bridge team during the maneuver. Layer 2 involves local workplace conditions, the environment, equipment design, and procedures that induce or allow those errors to occur. Layer 3 is latent organizational culture, the unseen social pressures and commercial priorities that guide decision-making from the top down. The analysis requires identifying the specific moment where vulnerabilities in all three layers aligned to bypass the ship's defenses. The ship's standard route from Civitavecchia to Savona is shown here in black, while the red line represents the non-functional deviation planned for the night of the accident. The deviation was plotted on a high-level paper chart with a 1 to 100,000 scale, rather than the detailed 1 to 5,000 scale local charts required for safe coastal navigation. Using this low-resolution planning, the captain established a 0.5 nautical mile safety margin for the sail past. This margin was fatally anchored to a generic point on the island, failing to account for the physical rocks extending into the sea. For a ship with an 8-meter draft, the 10-meter bathymetric line represents the absolute no-go area, yet it was not factored into the geometry of the turn. As the approach moved from theoretical planning to real-time execution, the margin for error vanished. During the final turn, the captain manually cut the safety margin in half, shrinking the distance from 0.5 to 0.25 nautical miles. Cascading mathematical and procedural errors compromised the ship's trajectory before it even reached the island. In maritime operations, Bridge Resource Management, or BRM, acts as the primary human defense system to catch individual mistakes. During the approach to Giglio, this system collapsed. There was no team briefing and no formal handover of control when the captain took the helm. Understanding this failure requires looking at the crew's cognitive state, specifically the compounding factor of off-watch administrative burden. Chronic administrative fatigue often shifts operator goals towards least effort practices and the normalization of routine violations. The ship's integrated navigation system, seen here among the bridge consoles, featured automated chart alarms that could have warned the crew. They were never utilized. This failure suggests either a shortfall in equipment-specific training for the officers or significant usability issues in the software interface. The bridge environment shifted into a space where operator errors were both induced and normalized rather than intercepted. This leads to the fundamental question of why such a high-risk, non-functional deviation was authorized at all. The request for the sail past originated with the ship's restaurant manager, who wanted to honor his native island. The captain agreed, intending to perform a salute as a sign of respect for a retired mentor living on Giglio. This represents a breakdown in organizational dynamics, the informal power of non-navigational commercial staff dictating operational risk. The presence of hotel department personnel on the bridge during the maneuver further distracted the captain from his role as team leader. Unmanaged commercial and social obligations effectively overrode the ship's hard navigational safety boundaries. The method of execution was also dictated by tradition. The close coast turn was performed manually. Safer, automated track-keeping systems were available, but were not utilized for the maneuver. In maritime culture, manual ship handling skills often carry more professional prestige than the management of automated systems. This cultural pressure can foster a chronic, risk-taking performance style among senior officers seeking to maintain their reputations. The cultural reward for demonstrating manual skill ironically dismantled the technological defenses designed to protect the vessel. When we overlay these three layers of failure onto the map, the trajectories of the social, workplace, and navigational errors intersect at the coordinates of the grounding. The disaster was the physical manifestation of unmanaged social pressures and workplace fatigue, defeating a compromised bridge team. Redefining cultural hierarchies is necessary to insulate the bridge from the informal power of commercial and hotel departments. Safety management must aggressively audit latent workplace conditions, like administrative fatigue, that drive rule violations. The industry must also mandate equipment-specific BRM, ensuring that chart alarms and safety contours are embedded as mandatory procedural requirements. We cannot change the human condition that leads to isolated errors, but we can and must engineer the conditions under which humans work to prevent